Happy morning to all. Happy morning. Today we are going to discuss about that extraction of crude metal and reduction of metal oxide. These two topics we are discussing. These two topics having a number of reactions, many reactions having. So first about the extraction of crude metal having roasting and calcination. The two important topics. What is about the roasting? Roasting means here the ore is roasted in excess of air. Ore is roasted, that means heated in the excess of air. That is about the roasting. What is about the calcination? Calcination means the ore is heated in the absence of oxygen. Okay, so do having a small difference and having a number of reaction, you must take the written practice. Okay, let us please all of you take the note. We can discuss one by one.
Today our learning objectives to learn about extraction of crude metal, and one more topic, reduction of metal oxide. So today we have to discuss about that extraction of crude metal and reduction of metal oxide. The last class we discussed about the concentration of the ore, that is about the gravity separation, fourth flotation process, leaching, and also magnetic separation. Today we are going to extract the crude metal. Okay. The extraction of crude metal from the concentrated ore is carried out two step. How much step? Two step. What are the two steps? One is conversion of ore into metal oxide of the metal. Conversion of ore into metal oxide. Second step, reduction of the metal oxide to elemental metal. Reduction of metal oxide. Reduction of metal oxide to elemental metal. These are the two steps. First step is the ore is converted into metal oxide. The second step is the metal oxide is reduced to elemental metal. Okay. Here in the concentrated ore, the metal exists in positive oxidation state. The metal lost its electron, so it exists in positive oxidation state. Okay. Hence it is to be reduced to its elemental state. From the principle of thermodynamics, the reduction of oxide is easier when compared to the reduction of other components of metal. Anyhow, before the reduction, how the ore is converted into oxides of metal. We can discuss how the ore is converted into metal oxide. Here's the first topic one. Conversion of ores into oxide. Conversion of ores into oxide. First one, roasting. Here includes, first one is roasting, second one is about the calcination. What is about the roasting? Here the concentrated ore is oxidized by heating it with an excess of oxygen. Here we are taking one of the ore, that is about that zinc sulfide. We can be called as a zinc blend. Am I right? Galena. Here zinc blend and galena is oxidized to zinc oxide and lead oxide. Am I right? So one of the sulfide ore is converted into their metal oxide. So I am taking three examples. Which are the three examples? Means galena. What is the formula for galena? PBS. Next one, zinc blend. Formula is EZNS. One more example I am taking. Copper glands. What is the formula? Cu2. Yes, these are the three words I am taking. First one. Here, the galena is oxidized. Oxidized. We are adding oxygen. We are seeing that on roasting. Oxygen and heating. First, the sulfide ore is converted into metal oxide. That means Pb on combines with oxygen we get PbO, and S on combines with oxygen to form SO2. Then we have to balance the equation. Here I have 3 oxygen, so make it 2 here. So how much lead is there? 2 lead is there. Then how much sulfur is there? 2 sulfur is there, so make it 2 here. So how much oxygen is there? 2 into 2 is equal to 4. 4 plus 2 is equal to 6. So make it 3 here. Now the equation is balanced. What about the second equation? Zinc blend on roasting with the excess of oxygen, that is O2, heating symbol. Zinc combines with oxygen, we get zinc oxide. S combines the oxygen to form sulfur dioxide. These are all gas, am I right? Gas. How can you balance the equation? Here also 2 oxygen, here also 3 oxygen, so make it 2 here. How much zinc is there? 2 zinc is there, make it 2 here. How much sulfur is there? 2 sulfur, make it 2 here. So, how much oxygen is there? 2 into 2 is equal to 4. 4 plus 2 is equal to 6. So, make it 3 here. Now, the equation is balanced. Am I right? Next one is about the copper glands. Copper glands ore is undergoes oxidized. What is the formula? We are using here oxygen, O2, undergoes heating. Here copper combines with oxygen to form Cu2O, cuprous oxide, Cu2O, and sulfur combines with oxygen to form SO2. How can you balance the equation? 3 oxygen, so make it 2 here. Now how much copper is there? 4 copper, so make it 2 here. How much sulfur is there? So make it 2 here. So sulfur balance. What about the oxygen? 2 into 2 is equal to 4. 4 plus 2 is equal to 6. So make it 3 here. Now the equation is balanced. Dear children, one more point is about the roasting. Roasting also remove impurities. Roasting also remove some impurities. Which are the impurities? Means arsenic, sulfur, and phosphorus. Listen, all of you. Sulfur and phosphorus are the polyatomic element. Oh, sulfur can be written as S8. Don't forget that. Phosphorus is also polyatomic element P4. Sulfur undergoes roasting with the excess of air. We get arsenious oxide. That is, arsenious undergoes roasting with the air or heating with the air. Excess air, we get AS2O3. We get a gas, arsenious oxide gas. How can you balance the equation? Here having 3 oxygen, here having 2 oxygen, so make it 2 here. How much arsenic having? 4. Then how much oxygen is here? 2 into 3 is equal to 6, so make it 3 here. Now the equation is balanced. Sulfur on reacts with oxygen, on heated with oxygen, excess oxygen. Sulfur combines with oxygen to form SO2. So how much sulfur is there? 8 sulfur. How much oxygen is there? 8 into 2 is equal to 16. Now the equation is balanced. Phosphor on heated with the oxygen, excess oxygen, we get phosphorus pentoxide P4O10. What is the formula for phosphorus pentoxide? P4O10. Am I right? Yes or no? Then phosphorus balance. Here oxygen having 10, so make it 5 here. Now the equation is balanced. Next topic is about the calcination. Calcination. What is about the calcination? What is about the calcination? Concentrated ore is heated in the absence of air. Concentrated ore is heated in the absence of air is called calcination. Here, during calcination, the carbonate ore is converted into metal oxide and carbon dioxide gas is evolved. Carbonate ore, don't forget that, carbonate ore is converted into metal oxide and carbon dioxide is evolved. For example, cerusside. Cerusside, what is the formula for cerusside? PbCO3. Cerusside. Calcite formula CaCO3. Calamine formula ZnCO3. Dolomite formula MgCO3 CaCO3. This ore undergoes heating. Lead combines with oxygen to form PbO. We get carbon dioxide. And calcium combines with oxygen to form CaO plus carbon dioxide. Zinc combines with oxygen to form ZnO plus carbon dioxide. Manganese combines with one of the oxygen, we get MgO. Plus calcium combines with one of the oxygen, we get CaO. So if we have here two carbon dioxide, we get 2 CO2. Now the equations are, everything are balanced. Here carbon dioxide is a gas, okay. Next about the hydrated ore. What is about the hydrated ore? During calcination, hydrated ore is converted into metal oxide and water. Here hydrated ore is, what happened here means it is converted into metal oxide and also water vapor. Otherwise water is also evolved. Limonite formula Fe2O3 3H2O. This undergoes heating. Here water is removed. So we get Fe2O3 plus 3H2O. Can you write? Next one about the bauxite. What is the formula for bauxite? Al2O3 2H2O. On heating we get pure alumina. What is the formula? Al2O3 plus 2H2O. Water. Next is about that reduction of metal oxide. Okay. How the metal oxide can be reduced to crude metal. How the metal oxide is reduced to the crude metal. Here we are using some of the suitable reducing agent. For example, carbon monoxide, hydrogen, aluminium. These are all used as the reducing agent. And also other reactive metals such as sodium, potassium, aluminium also here we are using. Okay, for the reducing agent. Here reducing agent depends on the nature of the metal. It depends on the nature of the metal. For example, carbon cannot be used as a reducing agent for the reactive metals such as sodium, potassium, aluminium, etc. Don't forget that. Carbon cannot be used as a reducing agent for the reactive metals such as sodium, potassium, aluminium. And also carbon monoxide also cannot be used as the reducing agent for the oxides such as ZnO and Al2O3. Can you understand? 2 points. One is about that. Carbon cannot be used as the reducing agent for the reactive metals such as sodium, potassium, aluminium. And also, carbon monoxide cannot be used to reduce oxides such as ZnO and Al2O3. Here, why the carbon and carbon monoxide cannot be used for the reducing such as some element. What is the reason? We can be explained to the elegum diagram. Okay, tomorrow I think that we can be start the elegum diagram. We can be neatly discuss that one. Okay, anyhow, today next topic we have to discuss about that smelting. What is about the smelting? Smelting. Okay. Here, what is smelting? In this method, we are taking a flux and reducing agent and also concentrated ore. What are the items we are taking? Flux, reducing agent and also the concentrated ore. This mixture is melted by heating at an elevated temperature. What is about the elevated temperature? For liquid, the elevation temperature is 100 degrees Celsius. For liquid, the elevation temperature is what? 100 degrees Celsius. For solid, the elevation temperature is about 240 degrees Celsius. Okay. Here, one of the flux we are using. What is about the flux? What is about the flux? Flux is a chemical substance that form an easily fusible slag with gang. Okay. What is about the flux? Flux is a chemical substance. This is one of the chemical substance. What purpose here we are using means it is one of the chemical substance that forms an easily fusible slag with gang. Okay. So here, for example, one of the oxide ore can be reduced by carbon monoxide. How the reaction is going on? Okay. Can you see any one oxide ore? I am taking one ore is called hematite ore. What is the formula? Hematite formula. Hematite ore Fe2O3. Hematite ore. We are adding one of the suitable reducing agent, that is the carbon monoxide. Here carbon monoxide combines with oxygen, we get carbon dioxide. Okay, carbon dioxide, and also we get an iron metal plus carbon dioxide. Okay, how can you balance the equation? Here having 3 oxygen, so make it 3 here. Here also make it 3 here. How much iron is there? 2 iron. Now the equation is balanced. Okay. Next. In this extraction, we are using a basic flux. What is a basic flux? Means a limestone, calcium oxide. Here, the silica, the gangue particles is in the ore, is in acidic in nature. Limestone combines with gangue particles, that is the SiO2, we get calcium silicate. That is about the slag. We can write the equation calcium oxide. Calcium oxide means it is a basic flux. Basic flux. And we are taking gangue, that is about the silica, SiO2. And both of them are reacting, we get calcium silicate, CaSiO3. Okay, CaSiO3, calcium silicate. That is called as a slag. Okay. The next one is about that. Next topic. The extraction of copper from copper pyrites. Listen all of you. Here we are taking copper pyrites. The copper pyrites, the ore is heated in the reverberatory furnace. Here what is happening here means copper pyrites is converted into iron sulfide and copper sulfide, and also we get sulfur dioxide. Copper sulfide is oxidized to form, iron sulfide is oxidized to form iron oxide and also sulfur dioxide. Iron oxide undergoes reacts with silica, we get iron silicate. These 3 reactions are going on. One is about that, we get iron silicate. Before that, the remaining metal sulfide, here some metal, after the formation of slag, we get some sulfide, that is about the copper sulfide and iron sulfide. These are mutually soluble and form a copper matte. Okay, to form a copper matte. Okay, first you have to write the equation. What is the formula for copper pyrites? CuFeS2, copper pyrites. This undergoes reacts with oxygen. Here, iron, that is Fe combines with the sulfide to form FeS plus. Copper combines with the sulfide to form Cu2S plus. S combines with the oxygen to form SO2. Okay. Then how can you balance the equation? Here we can be sulfide here having 2, here also having 3 sulfur, so make it 2 here. There is iron sulfide, make it 2 here. So how much iron is there? 2 iron. Then copper also balanced. Okay. Now the equation is completely balanced. Next about what happens is iron sulfide. Iron sulfide reacts with O2. This is iron sulfide is a liquid state. Oxygen is a gaseous state. So we get iron combines with oxygen to form iron oxide FeO plus sulfur combines with oxygen, we get SiO2. Here we can write the liquid state and about the and about the gaseous state about the sulfur dioxide, okay, SO2. SO2 is a gaseous state. Then how can we balance the equation? Here having 3 oxygen, here having 2 oxygen. So make it first 2 here. So how much iron is there? 2 iron. Make it 2 iron here. Sulfur 2 sulfur, make it 2 here. So how much oxygen is there? 22 is equal to 4. 4 plus 2 is equal to 6. We can write it as 3. Am I right? So the equation is balanced. Next about we are taking iron oxide. What is the formula for iron oxide? FeO reacts with the silica SiO2. We get FeSiO3, one of the slag. Okay. Iron silicate, one of the slag. Okay. Next, I told you about the matte. What is about the matte? The matte containing cuprous sulfide and also iron sulfide. Okay. Anyhow, this matte is separated from the slag and feed into the converting furnace. During the conversion, the Fe present in the matte is first oxidized to FeO. That is, iron sulfide is first oxidized to FeO. This is removed by the slag formation. The remaining copper sulfide, this copper sulfide is further oxidized, we get copper metal. Then how can you write the equation? First you have to write copper sulfide. What is the formula? Cu2, copper sulfide reacts with oxygen, we get Cu2O plus SO2. How can you balance the equation? Here having only 2 oxygen, here having 3 oxygen. So first you have to write here 2 here. Am I right? Next, how much copper is there? 4 copper, so make it 2 here. How much sulfur is there? 2 sulfur, so make it 2 here. Then we get 6 oxygen molecule. Am I right? Now the equation is balanced. Next about the cuprous oxide, that is cuprous oxide. What is the formula? Cu2O reacts with cuprous sulfide. Okay, Cu2, yes. So how can you balance the equation? Sulfur combines with oxygen to form SO2. How much sulfur is there? SO2 plus Cu. Then how can you balance the equation? So oxygen here having 2, here having 1, so make it 2 here. So sulfur 2, so about the copper, 2 plus 2 is equal to 4, 4 plus 2 is equal to 6. So you can put it as 6 copper. Okay. Then about the one more point, the metallic copper is solidified and it is blistered appearance due to the evolution of sulfur dioxide. What is about the blistered copper? That means 98% of pure copper is called blistered copper. How much percentage? 98. So try to remember this point. Next about that, reduction of carbon, reduction by carbon. Here we are using some of the reducing agent. That is about the coal, otherwise called, we can be say coke. Coke is the residue of coal. Okay, residue of coal. That is about the coke. Simply we can be say that one. It is about the carbon. Am I right? Carbon. First, we can be taken as a zinc oxide. What is the formula for zinc oxide? ZNO. Zinc oxide reacts with the carbon. Trimanganese tetraoxide, that is Mn3O4 plus carbon. Chromic oxide Cr2O3 plus carbon. Chromic oxide, that is Cr2O3 chromic oxide, these three we are taken as. What is the first one? Zinc oxide plus carbon. Then trimanganese tetroxide also reacts with the carbon. Chromic oxide reacts with the carbon. So carbon combines with oxygen, we get carbon monoxide. What is the remaining product is there? Zn plus CO gas. Next one is about that hydrogen combines with carbon combines with the oxygen to form carbon monoxide. Remaining is manganese. Am I right? 3Mn plus 4 carbon is there, so make it 4CO. 4 oxygen is there, so make it 4CO. Okay? Next about chromic oxide. The chromic oxide reacts with carbon. So we get carbon combines to oxygen to form CO and Cr metal, chromium metal, 2 Cr metal plus CO. Here how much oxygen is there? 3 oxygen, so make it 3 here. Now the equation is balanced. Am I right? Next we can be discuss about the reduction of hydrogen. Reduction of hydrogen. What is about the reduction of hydrogen? First you have to take one of the metal, that is about that metal oxide, silver oxide, Ag2O, silver oxide, Ag2O undergoes reduction by hydrogen. This hydrogen combines with oxygen to form water. What's the remaining product here? Ag. How much Ag is there? 2 Ag plus H2O. H2O is a liquid. Next about that, magnetite formula Fe3O4 solid state plus hydrogen. So what are the possibility? Hydrogen combines oxygen to form water molecules. What's the remaining one? Fe. We can written as Fe. How much Fe is there? 3 Fe plus H2O. How much oxygen is there? 4 oxygen, so make it 4 here, 4. Equation balance. The last one equation is about that, about the reduction of hydrogen. Nickel oxide NiO combines with water gas. What is the formula for water gas? Carbon monoxide gas and hydrogen gas. Carbon monoxide gas and hydrogen gas. That we called as water gas. This nickel combines with one of the carbon dioxide we get. One of the carbon monoxide we get carbon dioxide CO2, and one more oxygen from the nickel combines the hydrogen to form water molecule. What's the remaining one there? Nickel plus carbon dioxide plus H2O. This product is obtained. Then how can you balance the equation? Make it nickel oxide is 2, so nickel balanced. Then carbon dioxide and everything also balanced. Okay. Next about reduction of metal. Metallic oxide such as chromic oxide can be reduced by aluminothermic process. Here we are using aluminothermic process. Here the metal oxide is mixed with powdered aluminium and placed in a fire clay crucible. This is one of the fire clay crucible. Can you understand? Here magnesium and barium peroxide here we are using. It should be ignite. Okay, at the ignition mixture. Okay. So due to burning, large excess of heat is evolved. Before that you have to write the equation. What is about the equation means? Barium peroxide. What is the formula for barium peroxide? BaO2 reacts with the magnesium. Magnesium combines the oxygen to form MgO and barium combines the oxygen to form BaO. These are the equation. Anyhow, here we take that A mixture of powdered aluminium and chromic oxide, Cr2O3, chromic oxide, is what happened this equation. Cr2O3 plus aluminium, Al. So aluminium combines the oxygen to form 2Cr plus Al2O3. This is the equation. Don't forget that to write the equation. Okay. Next we are taking some of the active metals. Which are the active metals? We are taking boron trioxide, B2O3. Boron trioxide reacts with the sodium. The sodium combines with the oxygen to form sodium oxide and also boron, B plus Na2O. So how can you balance the equation? How much boron is there? 2 boron, so make it 2 boron. Then sodium oxide. How much oxygen is? 3 oxygen, so make it 3 here. 3 2s are 6 sodium. Second one is about that. Rubidium oxide. What is the formula for rubidium oxide? Rb2O3. This one reacts with the magnesium. Magnesium combines with oxygen to form magnesium oxide. Magnesium oxide plus rubidium, Rb. How much Rb is there? 2 Rb. So here we get how much magnesium is there? 3 magnesium. Okay, now the equation is balanced. Next about the titanium oxide, TiO2, and combines with the magnesium. This magnesium combines with the oxygen to form magnesium oxide. We get titanium plus MgO. How much MgO? 2 MgO. The equation is balanced. Next about the thorium, THO2, thorium dioxide, and reacts with calcium, Ca, calcium to get calcium combines oxygen to form calcium oxide, and also we get thorium, TH plus calcium oxide. How much calcium is there? 2 calcium, 2 calcium. Calcium is balanced. Next we can be discuss about that auto reduction. What is about the auto reduction? Without a reducing agent, the ore is converted into its metal. The ore is converted into its metal. Here we are not using any reducing agent. Okay, for example, mercury. What is the symbol of mercury? Hg. Am I right? Mercury is obtained by roasting of its ore by Cinnabar. What is the formula for Cinnabar? HGS. HGS undergoes roasting. Here HGS is a solid state. Okay, roasting, gaseous state. We get this sulfur combines with O2. We get Hg plus SO2. What is about the Hg? Liquid mercury metal. Okay, mercury metal. Okay, anyhow, today we discuss about that some of the important points about that extraction of crude metal, reduction of oxide metal. Here we learn about that roasting, calcination. Next about that reduction of metal oxide is about the smelting. Extraction of copper is a very important question. Extraction of copper, and also we learned some other reduction by carbon, reduction by hydrogen, reduction by metal. Okay, it's an important question. Next about we discuss about that auto reduction. Okay, please all of you learn this all equation thoroughly. Okay, anyhow today I am giving some important question, that is we have to write the assignment. Please all of you note the assignment. Number 1. First one is about the auto reduction. Second one is about the calcination. Third one, roasting. Fourth one, extraction of copper. Okay, calcination one equation is enough. Roasting also one equation is enough. Extraction of copper, I think that they have 5 equations. Try to write all the equations for extraction of copper. Okay, if you have any doubt, please ask me. Thank you all of you. Thank you. Have a nice day.